you already have the names and the formulas of these, so we're just going to do these two columns over here with the atoms versus ions. And you may just want to write down some little tricks and stuff. We'll do 3 of them together. We'll have you do 3 by yourself, just to kind of make sure that you're okay with it. So first thing, atoms are going to be counting individual elements. So like we're saying, like how many sodiums do we have, how many sulfurs do we have, each individual thing. Whereas an ion is a little bit different. An ion is looking up the charged particles. And this can be monatomic or polyatomic. And you want to refer to the name for this. And again, it'll kind of make more sense when we do a couple of these, just to kind of see what we're talking about. So if we're looking at our first guy, we're looking at sodium carbonate. And atoms are kind of the simplest, so we'll do the 3 atoms first, of like the first 3. So what you're doing when you're doing atoms is you're just literally counting each type. So we have sodium that we're going to count, we have carbon that we're going to count, and we have oxygen that we're going to count. So all you do is you look at your formula and you literally just say, okay, how many sodiums do I have? And it's going to be telling you with your subscript. So that means we have 2 sodiums. You look at carbon, and again, there's no subscripts. So that means there's just 1 carbon. And then if we look at oxygen, there is a little subscript, which means there is 3. And then you can also do like total atoms, and in this situation, if you add it all up, we have 2 plus 1 plus 3, we would have 6 atoms total. So it depends on how they ask you. They can ask you total atoms, they can ask you individual atoms, but that's what they're looking for. If we do our next one, potassium permanganate, we have K that we're going to look at, we have Mn, and we have oxygen. And again, you're just looking at the formula, and you're looking at how many there are. Now, this will not work for you if you don't have the right formula. So this is an important thing of like, you need to be able to write it correctly so you can get the right answer. But if we look at this one, K has nothing around it, so there's just 1. And then there's no subscripts, so there's just 1. And oxygen, we have a subscript here, so there's 4. And again, if you want to, or it asks you, you can do total atoms, which means there is 6. And the last ones that we'll do together for the atoms is we have this guy, we have chromium we have to worry about, we have carbon, and we have oxygen. Now when you have parentheses, it's a little more complicated because just like in math, when you have parentheses, you're going to distribute through with multiplication. So just be aware of if you have to do that or not. But if we look here, chromium, we have a little subscript that's telling us there's 2. If we look at carbon, we have 2, and then we have to distribute the 3 through. So mathematically, we do 2 times 3, which means there's 6. And last but not least here, we have oxygen. And again, we have 4, distribute the 3, so we have 4 times 3, which is 12. And again, if we add them up, that gives us a total of 20. I'm going to move the ions thing for just a second, just so we have a little room here. Like we said before, the ions, you're looking at your charged ones, and this is where you're looking at your name. So what we're going to look here is you're only ever going to have 2 types of ions, your cation and your anion. So what we need to do is, okay, what is my cation? My cation is sodium, which is Na plus 1. So what you're doing here is you're looking up how many sodiums do I have. So this is sodium, and you're looking right here, and that means there's 2. And then if you look at your name, the other ion right here is carbonate. So when we look up carbonate, what we're looking up is CO3 minus 2. And what you'll notice with polyatomics is if it's not in parentheses, that means there can only be 1, because we always have to use parentheses if there's more than that. So that means there's just 1 carbonate. And you can see it's close. I mean, there's sodium is an ion in an atom, but you can see the carbonate is not, because it's a polyatomic. And again, if you wanted to, you could say the total ions would equal 3. If we do this one, the next one here, the first ion we're looking up is potassium, which is K plus 1. You look at your K, there's no, there's no subscript, so there's just 1. And we're looking at permanganate, which is MnO4 minus 1. There's no parentheses around it, so there's just 1, which gives us total ions of 2. I'm going to move this up a little. And last one we're going to do together is this guy right here. So what we're looking up, our first ion is chromium 3, which is Cr plus 3. And again, you look at your Cr and you just look at your subscript. That's telling us there's 2. The other thing we're looking up is oxalate, which is C2O4 minus 2. He's in parentheses, so that's telling you there's more than 1. You're going to look right after your parentheses to see how many there are. And what that means is there's 3, which gives us total ions of 5. So take a second, pause the video, work out the rest of them, and then what you'll do is in like 20 seconds, once the video is turned back to on, all the answers will be there, and you can just kind of see if you were right or not, and you can check your work. So you can see at the bottom here, take some time, check your answers, make sure they're right, make sure I didn't make a mistake or anything. And again, this is just something like this is checking your understanding. Do you really understand what we're talking about? Or do you kind of get it and you can peripherally do it? If you can't nail this, then you're not going to nail it on the test. So you need to make sure you take some time and practice these so that you're aware of what's actually, going on.